Hi guys, welcome to Insight Tuesdays, navigating the world of observability. In the last few weeks, we checked out many aspects of observability. We learned how important is logging, metrics, and tracing. And we went through a lot of tools such as Jaga UI, Splunk, Grafana, and OpenTelemetry. So on your screens, you can see how observability looks in a nutshell. You start with monitoring and logging, and then you add instrumentation, that is traces, and then you debug the problems that you went through. So let's move ahead and today we'll talk about observability in distributed systems. That is the major frameworks or major infrastructure we have today in our cloud native architecture. Then we'll talk about a very crucial aspect of observability, that is alerting. And we'll talk about Prometheus, that was long due. And also I'll show you how you can implement alerting with the help of Prometheus and Grafana and also Slack. Then we'll talk a little about auditing and compliance. That is very essential when you are implementing observability into your systems. So let's get started. So we know that observability is looking into the problems of a system. Now let's talk first about distributed systems. That is, they refer to a collection of interconnected independent computers that work together as a unified system. That is the major architecture that is implemented today in cloud native architecture. In a distributed system, computers are often referred to as nodes or hosts, and they communicate and coordinate with each other to achieve a common goal. The primary characteristic of a distributed system is that they operate across multiple machines simultaneously, just like multi-threading, and on different locations. And they also share resources and responsibilities to enhance performance, fault tolerance, and scalability. It's more like a parallel connection in an electrical connection, if you are familiar with it. So even if one of these connection gets faulty, the whole circuit remains robust. Now, some of the aspects, or what you can say, some of the um key characteristics or services that get into distributed systems are cloud computing platforms such as AWS, Microsoft Azure, and Google GCP or Google Cloud Platform. Other than that, distributed databases also are consistent into distributed systems. Systems like Apache, Cassandra, MongoDB, or Google Spanner distribute data across multiple nodes. Not only this, these are some of the known tools, not known tools, but known pillars. But CDNs, that is content delivery networks, are equally into the distributed systems because they distribute content across servers. So in simple languages, whatever aspects or whatever tools or whatever technology contribute into distributed systems are consistent into the DS infrastructure. Also, you can also talk about the blockchain networks or distributed file systems, which are into technologies such as Python, and systems like Hadoop and Google File System, or also distribute data across multiple nodes for efficient storage. So these also are part of distributed systems. So moving ahead, we have phases of implementing an observable distributed system. So how you can do, like how you can implement observability into a distributed system. These are some of the steps. These are not the exact steps. These are just a framework, or you can say a skeleton of it. And at every step, you have to be precise. So to bring that accuracy, first of all, you have to define your observability goals. You have to clearly define the objectives of observability for your distributed system. You have to consider aspects like monitoring performance, identifying bottlenecks, tracking errors, and ensuring reliable operation. Not only this, you have to make sure that not that you're not um, bringing a lot of load or volume into your infrastructure that might slow it down. So that's why you have to define observability goals at first step. Second step is, of course, logging, metrics, and tracing. That is, we talked about it in our last session. That was the purpose of defining them earlier. So you are familiar with it and you have the tools in your hands. So you can implement it if you have a distributed system at your step. Third phase is implementing distributed context. We talked about distributed context. It is a tag or an ID, which it is relevant to the container or whatever, say the package going through this process, such as request IDs, user IDs, or transaction IDs, and it has to be propagated consistently across the service. What it helps correlate information across logs, metrics, and traces. So it provides a complete picture of the system's behavior. Then phase 4 is centralized observability platform. Say you have implemented logs, you have implemented metrics, and you have implemented traces all along your system. You will be thinking, or you'll be sitting at your chair, and you'll be thinking that yes, I have implemented the whole observability infrastructure. But the fact that if you invest in a centralized observability platform, it can aggregate and analyze logs, metric traces at once, and you have the whole picture at your hand, and you can save time. So tools like Prometheus, Grafana, ELK stack can help you. Also, there are tools such as New Relic, SonarQube, and Datadog, which you can integrate into your CI/CD as well. So you don't have to go somewhere else, and you don't have to leave your CI/CD behind to implement an observability platform. Moving ahead, we have some other phases such as automated monitoring and alerting. So setting up a monitoring and alerting with predefined threshold, that is something we will be talking about today. So let's skip this one. And you're already familiar with visualization and dashboards. If you create customized dashboards to visualize the performance and health of your distributed systems, you can identify trends, anomalies, and potential issues. So of course, tools like Grafana or Kibana are commonly used, and we are familiar with it. Again, we'll go through it today, so don't worry. And then, of course, you have to do documentation and training, because not just training of your colleagues or your organization people, you have to also educate the people that will be consuming your what do you say, your product. So at the end, the end user is secure, and you have to document the observability practices, instrumentation standards, what tags you're using, what are the IDs, so they don't skip it in the hassle, and tools used in your distributed system. So it also, you have to provide training to your operators, developers, and other stakeholders to ensure effective use of observability tools and practices. And of course, at the end, since CI/CD, or in full form, continuous integration and continuous deployment, is not a one-time process, observability going parallel to it can also not be a one-time process. It is an ongoing process, and at each step, at every time, you have to iterate and improve. You have to regularly review and update your observability strategy based on the evolving needs of your distributed system. You have to collect feedback from your operators and developers to identify areas of improvement. And when you implement that time to time, you create a robust environment or infrastructure at your hand. So these were some of the theoretical skeleton of implementing observability into your distributed system. Again, this is not this is not the last thing. You can add your steps also, you can choose your tools, but if you want it to be precise, just define your objectives at first. Now let's move on to our highlight, that's alerting. Since we are talking about logs, we are talking about metrics, we are talking about traces, what will we do if we are not getting the information on time? So that's why alerting is equally important as these three. So as I said, alerting in observability involves setting up notifications or alarms based on predefined conditions or promptly detect and respond to issues in a system. It is more like a fire alarm, and it goes on as per your thresholds. In the context of observability, alerting ensures that operators or administrators are notified when there are deviations from expected behaviors or when certain conditions indicative of potential problems are met. Some of the key aspects of alerting are that alerting relies on monitoring metrics such as response times, error rates, or resource utilization. If you remember, we talked about red metrics. That is, here we use it, and you also have to define thresholds for these metrics to determine when the system is behaving abnormally. So it is always, prevention is better than cure. So that is, what do you say? What thresholds can be, of course, static or dynamically adjusted. So you can also automate it, and they are based on historical data or trends. So if you want, you can use new age tools and make your stuff easier. Then you have to choose appropriate alert channels for notification delivery. Some of the common channels include emails, chat applications. I'll be showcasing Slack today. So, not like, or you can also use PagerDuty to streamline the incident response process. Then comes the utilization of anomaly detection techniques to automatically identify deviations from normal behavior. You can use predefined queries, you can use predefined tools. Some of the tools, such as New Relic, watches over such vulnerabilities and alert you right ahead. So also, just like we talked about, that it depends. It clearly depends on monitoring metrics. You have to clearly define the conditions that triggered alerts. You have to make sure that only specific events that are necessary are triggering the alerts. So you, it's not creating load on your system, and your operators are actually working over it. Also include relevant annotations so they know what is causing the alert. And you have to also establish feedback loops, because as I said, it is an ongoing process. It will give up alerts every time there's an anomaly, and you have to continuously upgrade those alerts, upgrade those thresholds, and analyze those alerts. If these alerts are increasing with time or something, or you have to change your technology, you have to add it, and you have to also incorporate feedback from operators and developers. That was mostly about alerting. Um, so that was just the definition, but we'll see how it looks like in few minutes. Let's talk about Prometheus first. It was long due. We also saw it in our metrics video. So, for definition, Prometheus is an open source monitoring and alerting toolkit designed for reliability and scalability in monitoring complex, dynamic, and distributed systems. It collects and stores time series data, providing a powerful query language. It has an own query language, that's PromQL for analysis. Prometheus is known for its simplicity, efficient data storage, and integration with Grafana for visualization. That is what we are going to do today. Uh, I'll demo you how you can use Prometheus as a data source into a Grafana dashboard and how you can create alerts. It also uses a pull-based model, and where it scrapes metrics from configured targets, making it suitable for dynamic and containerized environment. So this whole observability series is mostly about the containerized environment and the DevOps ecosystem, but you can also try it out for single applications as well. So let's move on to the demo. Right. So this is the Prometheus dashboard, and I have the data source here. And this is the Grafana dashboard, not dashboard actually, but the Grafana platform. So let's create a data source first. You can search data source right here. Actually have this one, but I'll show you how you can create one for yourself. We are using Prometheus. There are also other options that you can use. Right. Is the Loki one? Yes. Is Jaeger and also Zipkin. We talked about it in our last video for tracing, but today we'll be using Prometheus because we are focused on alerting. Right here, you can add a URL, not a URL, but a URL to your data source. And then, guess I'm gonna keep it mostly default. I can save it as right. Just a minute. Okay. So right here, I have this one is the same as this one because I created it earlier, but why bother? Now I'll create a dashboard. I'll create an alerting system, and we'll see how we can create a contextual alerting system. How can we can add thresholds and how we can see on a communication channel. So in my metrics video, we saw how we can create dashboards. If you haven't seen that, please have a view. It will inform you what is Grafana and how you can use it. Basically, it's a very easy tool and it's pretty easy to navigate. Like, if you want to create one of your own dashboards, you will go here and create a new dashboard. Add a visualization, add your query, add a data source first. We have all these data sources, but I'm going to use my older one. So we have a whole view. Okay. Right. So I'll add a new one. Right. So my data source was Prometheus test, right? And here we have to add a PromQL query. So this is the Prometheus query language. Okay. And I'll add those. I'll add it. This is a query for memory pressure, and if it increases, we'll create an alert right now for a single job. Okay. First, let's see how it looks like if we run the whole one. It will show you the whole many instances, but we need a single one. So I'm adding it here for a particular ID and a particular job. Right. So now we have a single job, single instance and a single job metrics. So we create an alert for this one only. It's a time series. Let's change this one. Let's look. Yes. Right. It looks better in this one. Yes. So I'm going to use this one and okay, and keep the unit. So I'm going to use a person matrix. Yes. So we'll have a simpler threshold. Don't forget to add the context so it will easier for you only to navigate it later. Yes. So now we have this memory pressure panel. Okay. And I have to create. Okay. I have to create an alert for this one. So let's move back to the home page, the dashboard. So what should we name it? Okay. Let's keep a uniform name throughout so it's easier to navigate later. You can do two things. Either you can add an alert while you have the dashboard ready, or you have an option there as well. I'll show you. Or you can create an alert from here for the same query if you want. We'll check it out later. Let's do this one right now. So right here you have to add the threshold. Let's remove these ones. We'll create another one. If you see this one, you have a function, right? You can also add your own customized query name, but this helps you to have the context. So this function is used over here when you add the expression. I'll add a classical condition because I have to add a threshold. Last time we had 58%, so I'm going to add it. The last count is 55, so we can create an alert right now. And we'll add the annotation here. And we'll create another alert. So it will be used when we'll be creating contact points and notification policies. Okay. So this rule will be evaluated up to 30 seconds. That's why we have to add it here and refine it. Okay. Now we have an active alert condition. Let's create another threshold. Just like we did the last time, the last count, like whatever the last evaluation was. I'm going to keep it 55 because we have it at 58 and we'll create an alert condition. Okay, that is okay. So the alert condition is created and you can see it's firing, right? So, and then we have to set the evaluation behavior as well. This is the folder where we'll be keeping the logs and the group. Here we set it up such as 30 seconds. So every 30 seconds, the rule will be evaluated, and this is the pending period. That is 5 minutes. If there are 5 minutes to up to which the condition stays or sustains, then it will bring you the notification. This is how the notification will come, and these are the labels. This will be used later on the contact points. Let's save the rule and move ahead. Okay, so we have created a new alert rule, that's memory pressure. And let's move on to contact points. This is for to add a contact when where it would contact you if the alert comes. So let's create a contact point. Let's keep the same context. I will use Slack here. And yes, this is the webhook URL. You can get it on your Slack channel. This is the text. Yeah, okay, we don't need this one. This is how you see your message in the Slack channel. Okay, so we now have a contact point. Where is it? Okay. It is not used here. That's why it's giving you a warning. We'll use it in a few minutes. Okay. Now we'll add a notification policy. We will add the alert, the labels we created in the alert rules. And no, this is choose a contact point. Yeah. You can also add the mute timings if the alerts are coming over and over again. You can also choose that, but we are not doing that right now. So you can see our new nested policy. And let's see if we added the right one. Yes. Okay. It will come up in 5 minutes. Let's wait till then. Let's go through the dashboard. Slowly. Okay. Yes. I shouldn't have kept it 5 minutes. I have to wait for 5 minutes. Right. Okay. Right. Now let's check if we get a response in 30 seconds. Mhm. Meanwhile, let's sail through the Grafana dashboard. Okay, it's taking a lot of time, but these are how you'll see those alerts, like memory pressure alert demo. And if you click on this one, you'll be redirected to the demo. Right now, I don't know why it's not taking this. Okay, but that is how you set alerts and view those on your connection channel. Now, we also have something else in our list today, that is auditing and compliance. That is another very crucial aspect. Actually, it's majorly hidden. It goes side by side when you're talking about observability, but it is equally important. So let's talk about that. First of all, auditing is, it is the same as it means in every other aspect of business or anything. And it focuses on reviewing and validating observability process to verify compliance with relevant regulation and standards. So, um, reviewing the audit trails and logs generated by observability tools. These ensure that the capture logs or whatever the logs are getting recorded are relevant to user activities, the configuration changes, and access attempts. It also verify the integrity of log data to maintain a reliable audit trail. Other than this, you in auditing, one has to conduct regular reviews of the configuration settings of observability tools and platforms. So it is up to date to the environment and the ecosystem of your cloud native architecture. Then you have to assess the performance and scalability of observability tools to ensure that they can handle the expected workload. So you don't overload them, or they don't get slowed down with the added baggage. So that you have to assess within the auditing as well. And audit also shows how observability tools handle sensitive data, because anyways they're processing it and going through it, especially personally identifiable information, also known as PII. So that that is must, because if you are taking account into observability, that means that you are adhering to security standards, and then leaking out or compromising sensitive data can take upon your reputation and can cause damage to your um, company and infrastructure as well. Also, you have to audit the incident response process related to observability. This includes reviewing procedures for handling security incidents, reporting the mechanism, and documentation of incident responses. These were some of the things that you have to do while auditing your observability platforms or your ecosystem. Now, let's talk about compliance. So as you can see them in this diagram, compliance, to fully comprehend the benefits of observability in relation to compliance, it is important to have a clear understanding of what compliance requirements involve. So compliance refers to organization following a set of regulations, including laws, standards, codes, and policies. which basically aim to protect the confidentiality, integrity, and availability of data and systems. Common regulations include GDPR, that is General Data Protection Regulation, then Health Insurance Portability and Accountability Act, that health redirects or in the context of infrastructure, and industry specific standards like PCI DSS, that is security standard. Um, and you also have to document how observability practices align with regulatory requirements. You have to create compliance documentation that outlines the steps taken to meet specific regulations, because not everyone or every stakeholder or every user is um, you know familiar with the concepts, or uh, might not be familiar with the standards you're using. So it is important to document those, so everyone or any new person or anyone in the team gets educated and aware. So also it is crucial for auditing. That's why auditing and compliance go hand in hand. Not only this, since we are talking about auditing and compliance, it is important to know about awareness, to talk about awareness and uh, t- um, taking sessions or attending sessions that clarify your observability objectives as well. So that is equally important. So keep learning, and that brings us to the end of this video. So if you like the session, you can hit a like and subscribe our channel. You can also connect with us on our community, and you can connect to me on my LinkedIn if you have any questions, or if you have any suggestions of what we should create, and what you want to know about the cloud native architecture or anything. You can add it into the comments. You can also ping me. So thank you for watching, and keep learning.